Hello and welcome to SDC2020. My name is Krishna Kumar Gavravaram. In today's presentation, we'll see how storage management is done using Swordfish API. Disclaimer. The information presented in this presentation is a snapshot of work in progress within the SSM twig of SNIA. The information is subject to change, and for current up-to-date information on Swordfish, please visit snia.org/swordfish. In today's agenda, essentially we are going to be talking about three different aspects. One, storage management using Swordfish, an overview, and we'll talk about a couple of models that have been developed within the Swordfish framework in order to take care of different use cases. And then we'll look at a typical Swordfish management architecture. Second, we'll look at how storage management was done using Redfish APIs and what was the need for the OEM extension. And briefly, we look at how Cisco extended the Redfish OEM extensions to Redfish in order to get a more comprehensive storage management, and how some of these made it into the Swordfish spec as well. And third, we take an existing Redfish implementation and see how that can be migrated to Swordfish with a minimal set of changes in order to get Swordfish compliance. First, the Swordfish storage management. Swordfish basically provides a scalable, RESTful set of interfaces and uses a standard data model, like the OData model, for storage management. Since its focus is primarily on storage, it has extensive ways or extensive definitions within its schema to manage storage resources and also the data services. It is an extension to DMTF's Redfish Scalable platform management, in the sense that an existing client or an application which is already using Redfish, when it migrates to Swordfish, the protocol used to move data in and out of the management server would continue to be same as the Redfish. That makes the migration very easy and seamless. In this picture, we are trying to see how Swordfish and Redfish are related. In the upper half of the picture, we see the service root of the management tree or resource hierarchy is still Redfish/V1, in the sense that the Swordfish definitely actually ties into the same the hierarchy structure. So we see Redfish defined resource types like chassis, storage controllers, endpoints, drives. All these continues to be there. And however, where the Swordfish comes into picture is underneath the storage hierarchy or the subtree. Swordfish has introduced a much more detailed set of resources, and how do you manage them, how do you configure them. And some of the things that are listed here is, for instance, a storage group or a storage pool, a volume, file systems, or consistency group, and endpoint groups, etc. It is not limited to these set of resources. As we go on, we will see there are a few more resource types that Swordfish has defined. In addition to resources, there are also profiles, and there are also ways to treat, how do you handle storage specific errors, events, and status codes, etc. As we kind of briefly touched upon earlier, Swordfish has kind of defined different models for different use cases, whether it's a full-fledged storage array, or it's a JBOD with a bunch of drives, or it can be a local attached storage system, in the sense you have a server with some amount of storage attached to it, or it can be in case of hyper-converged environments, the storage is shared across multiple different, is shared across multiple hosts, which are local to each server, as is slightly different from a true storage, shared storage across a fabric. In this presentation, however, we will limit the discussion to two such models. One is called SSC, a Swordfish standalone configuration. The other one is called SIC, which is called Swordfish integrated configuration. So moving along, so the highlights of a Swordfish standalone configuration is the logical storage system is instantiated directly under the service root. So what does that mean? It means that if we talked about the service root in the couple of slides earlier, so you have redfish/v1, and under the redfish/v1, there would be a storage node. So in the sense that the entire storage system is instantiated as one monolithic entity under the service root. And but within that storage subsystem, you have resources called storage controller, and which are actually already defined by Redfish schema or Redfish modeling. And this model generally is applicable to storage arrays. Why do we say that? If we look at a shared storage, which is attached over a network, so from a host perspective, or host or initiator perspective, that entire storage array appears as one system without having to expose the details of that storage system to the host. So how many controllers does it have? How many drives does it have? How are these controllers and drives are attached to? I mean, what is the physical composition of it? All that is kind of hidden from the host perspective. So for a host which is doing configuration management of such a system is slightly different from a host which sees each of these individual. That's where the other model comes into picture. So essentially, this model is more suited for a storage across a fabric, could be shared across multiple such hosts. And for instance, a volume in this configuration could be visible to n different hosts. And this kind of a system typically has a very well-defined storage services. Like you could do replication, you could do consistency checks, or you could do fabric, access control. Since these are across a fabric, you can say, hey, how do I permit? Which host do I permit? Which host I do not permit? It has a very extensive set of configuration because it is over a network and it is shared. The next, so a pictorial representation of this in terms of the management schema, we see that Swordfish has defined the logical storage subsystem as directly under the Redfish v1/storage. And within that blob, the storage controller continue to exist, but this is projected as one storage system. And of course, within that, you will also have the concept of pools. Like any standard storage management, you would have volumes, you would have storage pools. This diagram is not kind of capturing all the different pieces or components within that. But you could, like we talked about, there can be a group configuration, storage group, a storage consistency group, or endpoint groups, or other services that this system may provide. Now, the next configuration is a Swordfish integrated configuration. So here, the entire storage subsystem is presented under the computer system. And each of the physical components, like earlier, is modeled using Redfish chassis. What does that mean? It means a physical entity, something like a controller, storage controller, is under storage system/system instance / storage, which is a collection, / storage ID, and it's a controller gets listed there, one instance of the controller. And within that controller, you could have links to drives, which are again physical entities within the server. And it has links to, it has a volume collection. So the volume collection is contained within the scope of that storage controller instance, as opposed to a general volume collection that you would see in an array configuration or SSC configuration. So the scope of some of the individual resources are tied to a storage controller, and each of the storage controller is physically tied to a computer system. And this type of modeling is predominantly or mostly used in server attached storage. You can think of a typical server which has a bunch of host bus adapters or storage controllers. And under each of those storage controllers, it could be seeing a set of drives. And using those drives, you could be creating volumes. And that's how the hierarchy looks. So, so the SIC configuration is mostly suited for server attached storage. So here is the pictorial representation of such a model. You notice that under Redfish v1, we have a storage system link. There is a link going to the computer system, and the computer system is one such instance. So your URL representation would look something like Redfish /v1/systems and a system ID /storage storage ID, or an instance of storage, under which you will see all the components of that storage, be it links to its drives or a set of volume collection and things like that. Of course, once you get into the storage subsystem, a SIC configuration can also define services. So it will have a link to the services provided by that storage controller instance. And you would also have storage services from the root, the service root. So these are just a couple of models that we talked about here, but there are a few more models that are defined in Swordfish. Some of these details were already presented in the Swordfish deep dive. So that defines a service-based model and non-service-based model. So for purpose of this discussion, we just did a recap to just a couple of models, which is what the rest of the presentation is going to be predominantly on the service, non-service based SIC configuration. So in this slide, we now look at a typical Swordfish based storage management architecture. So here we look at a management client as a out of box client application. It could be running in another server, talking to the managed server over a network, or it could be running in a cloud kind of environment where it can manage a set of such similar servers. So even in case of if it runs on outside a server within the same or different network, it can manage one or more. So the picture, what it is trying to denote is there is a management client outside the box. It talks to the high-level web server because the communication is HTTP based. And then the web server in turn talks to what we can call as a Redfish/Swordfish engine, who is providing the translation from the native management attributes into map that into a redfish / swordfish semantics. So it adheres to the schema, and the data model is O data model, nomenclature is followed, and that's what we're trying to represent here. If you look underneath the hood, a typical system, you would have some kind of software or engine which is managing different aspects of the storage management. Primarily, you could think of the most basic one would be inventory. How do I find what is present out there, meaning in the system? How many volumes do I have? How many storage controllers do I have? How many physical drives do I have? So that basic gives you the inventory list. After inventory would be configuration. So you would, a typical management application would want to configure, like you want to create a volume, delete a volume, or essentially in a generic sense, you want to create something, you want to delete something, or change attributes to existing resources. You want to change a property or a set of properties for an existing resource. Or you could do some kind of a long-running operation, like, oh, I want to initiate something, and I'll come back and check. So so that part comes under configuration plus, actions. Attached to configuration would be profiles. So configuration gives you typically a low-level, knobs. But when you talk of profiles, we are talking about how do I batch them together? How do I apply a profile and get n different set of configurations defined or set up? For example, if I have application-based configuration. So if I'm running this application A versus application B, I want my system to be configured for A or B differently. Then I can these configuration parameters into a profile, and I do a single from a management application client point of view. So you simply say, go apply this profile, which in turn would do a set of operations underneath the cover. So configuration acts as a way for profiles to be applied. And then you could also do telemetry. For instance, you want to, once a system is deployed and it's in production, you want to see what are the trends, how are performance trending, how are error rates are trending, or how my CPU utilization, or several parameters. So things that a client would be interested in monitoring some of that. So there is a telemetry engine or piece of software, and associated with that would be diagnostics. So in order to do health checks, for instance, I could trigger a set of diagnostic tests, gather results, and that could be fed into telemetry. So as a time-based approach, I can see how my error rates are progressing. Or the other aspects of it would be bottom-up driven, in the sense something went wrong, a fault was detected. So the hardware underneath and the component, the system, the software component that is managing can receive events and faults or changes in the state. So all these are bottom-up driven events. All these different pieces of software kind of feeds into the Redfish Swordfish engine, which has a way to map this individual pieces of data into a schema defined, a standards-based definition, so that a management client gets a standards-based view of what about the system. So this is a very typical management architecture. Next, we look at some of the things that kind of Cisco did in terms of the management under the management umbrella. So just like any other management architecture, it provides basic, resource inventorying, configuration, change management, events and monitoring and telemetry. And in addition, it gives us a single pane management view, in the sense that I can do provisioning, meaning pre-provision, before even the server or the system is provisioned. So I can apply some of these pre-provisioning tools, and I can do configuration. And it has a unified data model, meaning whether I manage a fan through, or a thermal sensor, or I look at a storage component like a volume, or a physical drive, or IPMI sensor. So any of this. So the data, the modeling of each of these individual resources follow a unified data model. And the next thing is, you can be monitoring components within a system, or you could have a hierarchical model of n number of systems, and you can drill down into a system or a group of systems, and then study study what the trends within that system. So you could have a single pane management provides me a set of systems, and then I can drill down from one system into a component level. The next, the use of profiles, right? So the profiles is, like we talked about in a couple of slides earlier. Profiles provides us a way of batching a set of steps that are kind of canned into one, which can be applied to many times repeatedly without having to do individual steps. So so I can do, for instance, an applications case, use case specific configuration. That means if I'm going to deploy 100 servers, which are going to be used for a certain application, then with the click of a button, I can say, go take this profile, apply to 100 servers. So that kind of feeds into the bullet number 3, which is a scale deployment of large number of nodes, which have a similar use case. So because of this, I don't have to individually go service or apply configuration to individual servers. I'm doing that, instead of doing 100x, I'm doing it 1x. And that enables the quick deployment. The other aspect of it is, I can change the profile to meet my workloads. So I could have deployed a set of servers to operate for a specific application, but I may also want to reprovision or those servers at certain times to do a different set of workloads. Meaning, take for instance a database and analytics kind of application. I could be doing OLTP, and once at peak hours where I'm doing a lot of transaction processing, but at non-peak times, once that OLTP data is gathered, I may want to do a OLAP kind of analytics kind of application using the same data that has been generated. So I can go and change the profile to say, hey, during this non-peak time slots, I'm going to go and crunch this data, draw analytics, and do my analysis, and then draw charts and to see how the trending or things are happening. So the use of profiles provides us a very flexible, automated, less error prone, because I'm not doing it. There is no scope for, minimizes the scope for human error, because I create the profile once, test it, and it gets applied, and the application of these profiles makes it less error prone. So this is another thing Cisco UCS servers have kind of successfully deployed, and it has proven to be very useful in the field. And the last thing, of course, since we are talking in the context of Redfish and Swordfish, so all these applications, the client, the server, they are all standards based. So that helps us to deploy or work in a heterogeneous environments. We are all talking the same language. And in the last point here is, so we, in Cisco, we had implemented a Redfish based management, and we do have products out there. And under the storage umbrella, when we looked at the Redfish the Redfish schemas and modeling, there were some limitations. So in order to address these limitations, the DMTF Redfish spec has anyway provided a way to extend using what is called the OEM extensions. So we, at a resource level, we have added some extensions that makes the storage management much more richer. So we will look at some of those examples in the next coming slides. So in this section, we will briefly look at how storage management is done, can be done using Redfish modeling. So the Redfish model has defined schemas for physical resources, even before we go to Redfish. So if you look at storage management, so we can categorize the type of resources that are required. First, there is the physical resources, like you have a storage controller, host bus adapter, or NIC, or something like a physical drives. Then you have battery back units, which are contained within the storage controller for redundancy, power, and things like that. And then, so there are a set of physical resources. If you extend it to over a shared and over a shared storage over a fabric, you can also think of switches or expanders and a configuration that is related to those entities. And then there are the next category is the logical resources. So you can think of a storage pool. So you take a set of drives and call and group them into a storage pool, and attach certain attributes to the storage pool. You can say, oh, this storage pool has this level of spanning, meaning fault tolerance built into it. So physically, I can take a group of storage drives in one fault domain and take another set of drives in another fault domain and club them together and create a storage pool. So if there is a fault domain or one physical, one fault domain goes through a failure, then you still have redundancy. The second aspect is you could attach attributes like a RAID level, for example. I can say, hey, this storage pool can support these set of RAID levels. And when we extend this to, for instance, into NVMe space, you can define your NVMe sets, your endurance groups, and things like that. So, and essentially a storage pool is you're taking a bunch of physical resources and grouping them into a logical resource. And that logical resource becomes a manageable endpoint. And similarly, volumes. Volume is now riding on a storage pool, and then it inherits certain properties, and it can also have its own properties of its own. And you can think of storage groups. So you can create storage groups. You can create consistency groups. You can do endpoint groups. So all these things are kind of logical resources. Then storage services. The third one would be a storage service. So you can say, hey, now that I have all these things created, I want certain type of services on top of it. So I want to create a snapshot of a volume. Now, that service is going to result in creation of another volume, but there is a peer-to-peer relationship as opposed to a parent and child relationship. So volumes can have snapshots, you can have clones, in general, a form of replicas. Or I can say, hey, I want to do certain type of operations, like I want to do consistency check periodically on this, or I want to do RAID migrations of this volume, or I can do some kind of background tasks to check if I can migrate data or rebuild data, things like that. So those are all, some of these come under storage services. And the third one would be, like we kind of talked about profiles earlier on. Yeah, profiles is a very much part of management. So I can apply a profile for a specific use case, or for specific hardware-based profiles, depending on the capabilities of hardware, or in terms of applications, depending on where this system is going to be deployed, depending on the use case, I can say, hey, these are my application profiles. For this application, I'm going to set it up this way. And finally, we're going to talk about events and faults. So although Redfish does have faults and eventing mechanism, some of it has to be a little more fine-grained and has the color of storage-specific coloring. So in the sense that it has to be a little more detailed. So these are some of the things that needed to be considered and needed to be extended. With that, so in this context, SSM Twig has already come up with a document to standardize how events, errors, and faults for the storage subsystem shall be managed. So there is some guidance on what type of error needs to be generated for a certain condition, so that it is very precise and it conveys the right meaning to say that, hey, this is what happened in your storage subsystem. And eventing and faulting follows the similar model. So there are very fine-grained events and status codes, which will kind of translate into upper level, HTTP level statuses, but has some guidance on, based on the storage subsystem, errors and events, how do you map these equivalently? So there is a document which kind of details, which goes into much more detail in that. So we look at briefly a few of the extensions that we did. So for storage controllers, for storage controllers, some of the status codes have been enhanced in the sense, my flash component in my controller is defective. So there is a flash degradation within my storage controller. That could be one, or in general, status indicators. So we have expanded to a much more greater detail what are all the possible status codes that controllers can have. Or some controllers have the battery back unit. And so the battery back unit itself is a manageable component in the sense you can do learn cycles. So to make sure that the life of the battery is predictable. So you could initiate relearn cycles to see how quickly it can ramp up the charge, and how long it can hold the charge and things like that. So there's a whole set of management parameters for BBU units, so BB units. So that has been added. And diagnostics. So in terms of diagnostics, so we can think of storage controllers triggering several faults, be it flash degraded, or some other kind of indicators, or even battery back unit having going through some error conditions. So a whole set of diagnostics have been added. And you go to next to physical drives. So in physical drives, so again, the enhanced status indicators and health monitoring. So we could think of things like smart data, where we capture errors reported from the drive. So drives inherently are doing some kind of error gathering, and they're tracking some of the smart parameters, and those can be reported and can be enhanced to draw slightly higher level conclusions, in the sense based on how the certain smart parameters are showing up, or indicators are can be consolidated into a more user understandable or user consumable error code. So you can say a failure is predicted, for instance, based on these set of parameters. I'm going to say a failure is predicted, or life of an SSD could be going, is trending down. So things like that. So that is diagnostics. And in terms of operations, you could initiate some of the operations for rebuild, patrol reads, or you can proactively initiate some of these to make sure that the health of the drive is captured correctly and also communicated to the management application. So we now move into the logical resources. So some of the logical resources that are not available in Redfish are the concept of a drive group, or drive spans, or physical capacity as a pool capacity, and sparing models. How do you address spares, things like that? So in Swordfish, the concept of the drive group as an OEM property or an OEM resource is now mapped to Swordfish storage pools. And drive spans is, as Swordfish has defined it as spans. And the consolidated physical capacity is defined in Swordfish as a capacity source. And spares, how do we do spares? So I want to add a spare to a physical drive. So if a drive goes down and it is part of a storage pool, which impacts the health of a volume which is hosted on that drive storage pool. If a physical drive goes, how do I automatically, if a physical drive gets to a faulty state, how do I automatically switch to its spare? So that definition is defined in spare resource set, and how these things have to be managed. So these are equivalently mapped to an OEM to a Swordfish resource type. Then we look into the volume as a resource. So volume enhanced properties to start with. So although volume is defined in Redfish as a resource, it has taken a much enhanced set. It has its properties have been enhanced under the Swordfish definition. So some of the things like policies on a volume. So how do I do for example, the cache policies? How should my read cache? Should it be enabled? What are the attributes for a read cache, write cache? When an IO goes through a volume, do I want it written all the way to the backup media, or depending on my controller, whether it has a power backup, can it be written to the cache and then so all those parameters. And in addition, the usage. So I can use a volume as a boot volume or a cache volume, in which case a volume acts as a cache to another data volume. So then there is so the use case for the volume is definition and volume operations. So I could be able to trigger a consistency check on volume to make sure that my the rate volume is operating most efficiently. So if is the data consistent and striping and mirroring across multiple physical drives? Is it in a good state? Or if a drive has been replaced or it went down during within a storage pool and it comes back up, I want to rebuild. So I want a volume to be rebuilt. to start with, or I want to migrate a RAID level. So I have a RAID 5 and I want to make it RAID 6, or I want to do RAID migration. Migration can happen for several reasons. Maybe as a space saving or capacity management, I can migrate to a different RAID level. And so these are some of the things that have been added into, which comes natural to in Swordfish. So here in this slide, we trying to map how under a Cisco OEM tab. So we have some of these properties. This is a minimal set that we are trying to capture. So you see the RAID level, which is an OEM property, has been mapped to RAID type, and then the cache, different types of caches, the write cache, the read cache, and read ahead policy and volume policy and things like that. So, and available size. So this actually reflects to the remaining capacity in the pool, as opposed to a volume. So we capture that within the storage pool where this volume resides, there is this additional capacity. So, and then the volume use case. And another important thing is the encryption. So encryption, that is something that we've added in the storage controller a few slides ahead, which I didn't talk about, is how do I manage encryption at the controller level? So I can enable, disable encryption, or how do I do key management? For instance, if I want to do a rotating key for key management, so does it talk to an external key management server? So some of these things are added in under the controller, and you can enable, disable at a much finer resource level called volume. In the next slide, we talk about the OEM actions. So like I kind of said earlier on, so you could be doing a consistency check on a volume. So you can start consistency, you can cancel consistency, you could do patrol, read, you could do RAID reconstruction. So some of these actions are equivalently mapped into Swordfish consistency group storage service, and then there is a change RAID layout properties defined in Swordfish. Moving on. Yeah, so finally, we talk a little bit about the service profiles and storage events. So the service profile, as we had done in UCS, servers, there are different types of service profiles. But for the storage specific ones, Swordfish has defined its own definition of profiles. So for storage management, the profiles provide us all types of profiles that you can do. You can say, I want to manage my storage subsystem for this application or this use case. And that means I can define a profile and I can apply that profile in a standards way as opposed to an OEM specific way. So any client application, for example, which implements storage profiles can now talk to a Cisco UCS server in a standards compliant way. And storage events. So we were tracking a lot of events, error cases, and how do you, every event when an event gets generated, we categorize that. Is it just an informational event, or does it need to be propagated up to a fault? So if a application is listening to certain faults, so what is the mechanism to propagate that as a fault as opposed to an event? And all these things were done in an OEM way. Now, by moving to Redfish events, which is present in Redfish, but what the Swordfish has done is taken these events and provided some guidance to how do you generate an event for a storage specific error case or information, or what, how do you take the redfish events and map it to a storage specific way? And there is some guidance provided on that. So in addition to implementing Swordfish APIs, an implementation, if it can look into this user guide for events, errors, and status codes, that will make it a much clearer and much richer storage management experience. So, so there is this user guide, which can be again found in under SNIA.org/swordfish umbrella. Along with the spec, there is a bunch of documentation on some of these supplementary documents that can be used to understand how a server and a client can kind of standardize the error cases, the faults, and the events. So the final section of this presentation, we move on to considering there is a redfish implementation exists. What does it take for that to move to a swordfish based implementation? The minimal set that is required, the minimum set of changes that are required in order to get swordfish compliance. So that brings us to the next section. Migration from redfish to swordfish. So in order to migrate to swordfish, so the first thing that is required, so we are essentially, in this case, we are in the next few slides, we are talking about what are the tweaks or what are the changes that need to be done for an existing implementation. So it will be more like deltas. So if you have done this, you need to change this to this in order to get compliance with swordfish. So in that context, we are only talking about a minimum set requirement here, and a full-fledged swordfish implementation. Beyond this, it's up to the implementer. You can go take it to any length. But in order to get compliance or swordfish compliance, this is the recommended minimum set. So the first thing that we need to do is there has to be a features. I mean, of course, even before the features, so there must be one or more version properties for the integrated redfish and swordfish implementation. So the version number has to be fixed. Second, under the redfish v1, there has to be a features resource collection, and we will see what features are required in next couple of slides. And swordfish implementation should support get on all system objects, whether it is storage or non-storage. A get has to be supported on all objects, and get on all object properties. So I should be able to go read what is there. Get essentially means I should be able to read the objects and its properties. And under the redfish v1, a storage collection has to be instantiated, and under the storage collection, a storage instance should have a storage pool. The pool can be empty, but it should be there. So we will mention that. And for the pool, there has to be a capacity source has to be there, and a volume collection. So these, when we are talking about pool, capacity, volume, we are talking about collections here. So it means the collection can be empty, but the collection has to be there. Must have a features registry and with at least swordfish discovery. So we said, so there has to be a features under the service route in the previous slide. So under the feature, the minimum requirement is to have support swordfish discovery as a supported feature. So a pictorial representation of that would be, so if you look at this diagram, so we have a redfish slash V1, and in the redfish semantics, you would see a redfish V1 systems, which is basically the computer system collection, and followed by a system ID. So that is an instance of a system, and you have a storage collection within that system. And under the storage collection, you would have an instance of a storage ID, which typically would mean a storage controller, right? But in addition to that hierarchy, we need, for Swordfish, under the service root, we need to have redfish slash V1 slash storage systems. So, so you need to have the storage system collection, and under storage systems, you need to have an ID, an instance of storage system ID. And a computer system would have a pointer to the storage system. And in addition to that, you also should have a redfish slash V1 slash storage. And under storage, you could have your individual storage instances. Now, the storage ID or an instance of storage, which we get when we traverse through the computer system, would actually have a link to a storage system, the same storage system under the storage collection under the service root. And the next aspect of it is, under a given storage ID, the concept of a pool, a storage pool, has to be created. So essentially what that means is all the capacity sources under that, the storage ID would be a set of drives or a set of, it could be any capacity source. So we for details, you should look at the capacity source, the schema, to see that what are all the different types of entities that can form a capacity source. So for this example, since we are talking on a SIC configuration, it can be, you can treat that as a set of drives. So under a storage controller, you have a set of drives. So you need to create a storage pool, at least a storage pool collection. If there are any drives, you will create a storage pool instance. And you could now carve it up. If I have 8 drives, you can say my 4 drives form storage pool ID1, and the remaining 4 can form a storage pool ID number 2, or at least the collection as an array, as a collection defined in the schema shall exist. But it can have 0 or more storage pools. So this is another change from redfish. So earlier we would, in the redfish model, you would have had under storage ID, you would have a volume collection and a link to set of drives. So you can denote the physical drives that are coming out of, which are under that storage controller as you would have links to them. Here, you group them into a storage pool, and under a storage pool, your volume collection, which was directly under the storage ID instance, now gets plugged under the storage pool. So I can have a volume collection under a storage pool, and within that collection, I can have a number of volumes. So from an implementation standpoint of view, so I can say I have 8 drives under this controller. I create 2 pools, with one with 4 drives, another with another 4 drives. So there I have under pools collection, I have 2 pools, storage pool, pool 1, pool 2. And under storage pool 1, I will have a volume collection. If I have created any volumes on that storage pool, then under that collection, I will see that volume. Say if I've created 3 volumes under that storage pool, I could say volume 0, 1, 2. And if I've created volumes on a different storage pool, they will have that pool. There will be a pool for that storage pool, a volume collection under that storage pool, and those volumes will be listed there. So essentially what we are saying is it is a minor tweak to move the volumes collection under a storage pool and instantiate a storage pool collection and a storage pool ID under the storage, a given storage instance. So, and in addition to that, so we talked about swordfish discovery. So you could have a swordfish discovery as one of the features under the service route followed by features. We will see in the next slide how a discovery, what is the swordfish discovery essentially means I should be able to go and discover all the storage components within the system. So this would be a minor set of tweaks in order to move to a swordfish-based implementation from Redfish. So here in this slide, we are kind of formalizing the URL representation. So essentially for an SIC with existing Redfish implementation, you have redfish /v1/systems/system ID/storage. That's in the existing Redfish implementation. At least one member. So that now with the swordfish-based implementation, we are going to add redfish /v1/storage systems and have a features registry under the service route. And within that features, the minimum set that is required is swordfish discovery. And in addition to this, under the computer system, the hosting rules property has to be set to storage system. And continuing on, so we are talking about, so under a storage ID, so you need to have a storage pool and a pool ID, and you should have under the storage pool instance, we are going to have the volume collection. So we talked about this earlier based on the picture. So, so these are the minimal set requirement for in order to migrate from Redfish to Swordfish. And I think that kind of brings us to the end of the presentation. And thank you for watching this presentation. And here are a set of references. So the Swordfish specification and mockup. So as I was saying, so if you go under www.snia.org/swordfish, you not only have specs, you have the schema definitions, you have the mockups, you have the user guides and practical guide. So the practical guide and user guide helps a developer to use as mockups, and how it kind of provides you a step-by-step method of how do I go about implementing this. And so if you have any questions, if you have any suggestions and comments, and you can go to swordfishforum.com, and then if you want to, the technical group, the Swordfish specification and other related user documentation is all discussed and generated under the SSM twig within SNIA. And if you want to join, and if you want to be an active contributor to evolving the specification, please do join SNIA, SNIA.org forum SMIs about join. So that's the web link to join and contribute. And that kind of brings us to the end of the presentation. And thank you very much.